the indeterminate forms we use to find the limits, okay? So if you see, when you're plugging the, the function value, and if you see either form, either 0/0 or infinity/infinity, then we call those kind of forms as the indeterminate form, right? So if you see indeterminate form, then you could apply the L'Hopital rule. L'Hopital rule says that finding limit of the rational function f(x)/gx is always equals to find the limit of the derivative of those. Okay. So now if you want to find the limit of this function, when x goes to 2, what you will get? If you're plugging simply 2 here and there, you will get 0/0, right?
Right.
Then you have to apply this. This rule says that finding limit of the function is always equals to find the limit of the derivative of these two. So if you find the derivative of x minus 2, which is 1, the derivative of x squared minus 4 is 2x, right?
Yes.
Now, this is easy to find. When x goes to 2, your answer is 1/4. Now you see the good number, right?
Yes.
So this is very good, useful, application of a L'Hopital rule. So that means you could do this problem in two ways, either factoring or using L'Hopital. Okay. So this section
Yes.
is almost about finding the limits for the, indeterminate form problems. Okay, so I have included several examples. Okay, so you could think about those things. So that is here, but there is another, type of indeterminate problems, which is called the powers of the indeterminate forms. Once you see this kind of, answers in your limit problem, again, answer is, indeterminate form. So either 1 to the power infinity, 0 to the power 0, or infinity to the power 0. These all, don't have a finite answer. So for that reason, again, you have to use the L'Hopital rule. For these kind of problems, you have to, approach in different way before applying into L'Hopital rule. Do some, do some alternate things, techniques to change this form into either 0/0 or infinity/infinity. Do some math to, change these kind of forms to 0/0 or infinity/infinity form. Once you have these kind of forms, you could apply the L'Hopital rules, whatever you learned in the previous section. Okay. So I have explained here, explained a lot of problems, okay? How to use, the power rules. Okay. So let us look at one problem. Okay, I'm thinking, how can I? Oh, okay. So look at this problem: sine x to the power x when limit x goes to 0, right? So now the thing is, if you're plugging 0 directly into this function, what you will get? You will get sine
Uh,
0.
over
Sine,
0.
yes, sine 0 is 0. X goes to 0. So you will get 0/0 form, which is indeterminate. So anyway, you have to use the L'Hopital rule. Now the thing is, you don't have these kind of forms. What you want to do is you have to transform or change this problem into this kind of indeterminate form. How do you transfer? To transfer these kind of things into another way, so you have to use, these guidelines. Okay, what you want to do is um, take the base function as fx, take the exponent function as gx. Okay, that means this problem is in the form of fx to the power of gx. Okay, remember last time I told you e to the power ln of, okay, any function here, any function. So say here I'm taking one function. I already use f and g here. Let me use some different function. E to the power ln of some function hx is always going to be what? So this is one major, the general property of exponential function. Exponential of any ln function is always going to be inside function. Okay. So if you use this property here to this function, you could think of f to the power g as a new function that is equals to hx. That means what? If you apply this result here, you could rewrite e to the power ln of f to the power g function as what? F to the g function. Okay? So this is very, very basic property we have for exponential. If this is the case, now what you want to do? You want to use some log properties. Okay? So now your task is what? Your task is to find the limit of x goes to 0 of that. Okay? So what I'm going to do is, I am only considering this function. Okay? So limit x goes to 0 of sine x to the power x is always, okay, equals to, right, limit x goes to 0. Now you could think of this is f function, this is g function, this is f to the power g. Okay, but f to the power g could be written as like this. So that means instead of these two, now I'm going to replace e to the power ln of sine x, this all to the power x. Do you see why?
Yeah.
Yeah, because of this property. This is equals to e to the power when x goes to limits. So you could put that limit there. Okay. Now your task is to find this piece. Okay. So that one we are taking, let L be the number which is limit x goes to 0. I'm focusing only this piece, right? Forget about E for time being. Only find the limit of this
Mhm.
guy. So now I'm keeping that as one number L. Okay, so your task is to find this limit. So now, how do you find these limits? Okay, use some log properties. This could be written as limit x goes to 0. This x could be pulled in front of the log. This is simply the log property. Okay, now this could be further written as ln sine x over, if you move this x to the denominator, you could write like that. You see?
Yes.
Okay,
Yes.
now plugging the limit 0, what you will get? When x goes to 0, you will get here sine 0. So you will get basically ln 0 over 1 over
1 over
0,
0.
which is infinity. What is ln 0? Now think about the log function, ln function. Remember last time we discussed about ln function. You need to find ln 0, right? So
Hmm.
ln function is going like that. When x goes to 0, this is x. When x goes to 0, function going to negative infinity. Do you remember? So ln 0 is basically negative infinity. So this is now infinity over infinity form. I'm going to use the L'Hopital rule now because of infinity over infinity form. So I'm going to use the L'Hopital rule. That means what? That means simplifying the derivative of these two functions. Okay. So what is the derivative of ln sine x? X is 1 over x. So your you could think of this as u. So ln u derivative is 1 over u times u prime. U prime is the derivative of sine, which is cosine x, right?
Yeah.
Okay. Now, okay, so now here you will get negative 1 over x squared, am I right? The derivative of 1 over x squared is
Right.
1 over x is negative 1 over x. So you will get cotangent. Mm, so it is cotangent x over negative 1 over x squared. Now we will check whether what you'll get. If x goes to 0, what you'll get. So there are a couple of problems. You have to do certain number of times to get the good number. So whenever you get, infinity over infinity, keep on find the derivative one by one and keep on doing. Okay. You see now, again, I'm getting infinity over infinity. That means you have to take one more derivative of cotangent x and the negative 1 over x squared. Does that make sense? Okay, you if you want, you could rewrite this as like limit x goes to 0, pull the negative sign outside of the fraction, and
Yeah.
this x squared flipping and going to the numerator, right? And this
Yes.
this cotangent could be written as 1 over tangent, so it will be tangent, right?
Yeah.
Yeah, you could do that. Okay, now what I'm telling is when x goes to 0, you will get again 0 over 0. Am I right?
Yeah.
Okay, what I'm telling is whenever you see 0 over 0 or infinity over infinity, keep on finding the derivative, right? So I am
Right.
doing one more time finding the derivative. So what is the derivative of x squared?
2x.
2x. What is the derivative of tangent x?
Uh,
Yes. Now plugging 0, you will get good number. What is that? Secant 0. What is secant 0? Correct. It is 1. Cosine 0 is 1. So 1 over cosine 0 is 1 over 1,
it's-
which is 1. Okay.
okay.
Okay. So when x goes
Right.
to 0, the numerator will be 0 over the denominator is 1. This is a good number, right?
Yeah.
Okay. So you are getting 0. What was that? That was my L. You remember? I'm finding L, right? The exponential piece. So we got the answer for L. L is simply 0. That means if you plug in here 0, you will get the final answer. This is the actual problem we are working on, remember? So
Yeah.
the actual problem can be written as e to the power of limit of that. Limit of that is now 0. We got. Therefore, the final answer is simply e to the power that L. Okay. Therefore, the final answer limit x goes to 0 of sine x to the power x is nothing but e to the power L. But now L is 0, so e to the 0, which is 1.
Right.
You see now? So that's what L'Hopital rule says. So I have included so many problems here you could work on and try to understand these steps. Okay. The key point is look at the problem. Whenever you see this kind of indeterminate powers, use the ln of that the given problem like this. Write down with ln of the given problem, then try to find that limit by putting into fractions like I did here, numerator and the denominator, and check whether you are getting either 0 over 0 or infinity over infinity. Once you get that form, simply find the derivative of both. Do the uh, follow the procedures until you get a good number like this. Yeah, there are several ways. Yes, that is also one indirect way of applying the L'Hopital rules, the one you are talking. Yes, you will get the same answer. Okay, so that is about using the L'Hopital rule 5.6. Now 5.7 is simply the talking about the inverse trig functions. Okay, so
Yeah.
this is just the inverse of the function, right? Remember, suppose if you are given a trigonometric function, say sine x. Remember x? So remember here, x is the
Yeah.
domain, right? This domain, normally we have an angle, right? So you could
Yeah.
use either degrees or radian, right? For example, if you want to find, say, sine of pi over 2, we know now this is in radian, basically 90 degree. So you will get the answer, which is 1, right? So the range is y and the domain is x.
Yeah.
Okay. So the domain of sine function is, remember the sine graph. Sine graph is oscillating like this. So this domain of sine graph is, this is domain line going all the way from negative infinity to positive infinity. But the range is y value. So range of the sine graph is The smallest value you will see negative, or the highest value is 1, and the smallest value, this picture goes like this. Smallest value is negative 1. Therefore, the
Right.
range, yeah, the range of sine x is the possible y values, which is negative 1 to 1. Okay, this all you already learned about, drawing sine graphs, trigonometry. But here you are talking about the inverse of the trig function. Okay, so the inverse of any, for example, sine x could be written in two different ways. Some book use, arc, right, sine. Some book use to the power negative 1 for the inverse. Okay, so you could use either way.
Yeah.
So no confusion. This is not negative power 1. This is inverse notation. Okay, no confusion, right?
Right.
Okay, so this is just an inverse notation. So this is not equals to 1 over sine x. So you should not interpret in, mistaken way. This is not correct. So this is just a notation we use for the inverse, like a negative 1 power. Okay,
Yeah.
so you could use either one. But here, if you have a function, say you are given arcsine function. Now this is nothing but the inverse of sine function. Again, this is also a function, right? Now for this function, the domain is going to be what? The domain is basically going to be the range of the sine function. You have to, flip around the domain and the range for the actual function, you know,
Right.
to
Yes.
to to define the domain and the range of the new function, which is inverse function. So if you look at here, the definition, it says clearly, right? Now you see the domain of this inverse function, that is negative 1 to 1. Why it is? Because the range of the sine function was negative 1 to 1. So the range of the sine function is basically the domain of the arcsine function, inverse function. So I have to flip around and check. Make sense?
Yeah.
Okay. But for the range of the inverse, right? The range of the inverse, normally, you know, the range of the inverse function supposed to be the domain of the original function. The domain of the original function is actually negative infinity to positive infinity. But remember, we restrict our range to negative pi over 2 pi over 2 without considering all the values. We simply, restrict our domain as negative pi to pi, negative pi over 2 to pi over 2 for the original function. Then flipping around, we use this because to preserve function as, one-to-one function. Okay, so you will learn those things, deeply in cal 2. So at this point, you just look at these things. Okay,
Okay.
right? So that's what they have explained here. You see now. So even though the domain of sine function is all the way negative infinity to positive infinity, we simply restrict the domain to negative pi over 2 to pi over 2. So you will consider only this piece for the inverse function. Okay, that's what everything is explained here in clear way. At this point, you just look at these graphs. These all about, inverse functions graph. Simply flipping around the actual graphs: sine, cosine, tangent, secant, cosecant, and cotangent graphs. Okay, so these are simple problems they will ask you to find out. Okay, now tell me, evaluate the function value. You need to find the answer. Remember, now you are flipping around, right? So your answer of the given problem is nothing but an angle. Do you see that?
Yeah.
Because this is inverse function. Inverse of the value will give you the angle. Earlier you had what? The function has the angle, then you found the value. Now value is inside because of the inverse. Okay. So the question is now, you are asked to find arc sine of negative 2 over square root 2. What does mean by this? This means they are asking, hey, sine of, suppose say this answer is, say x, I don't know answer, right? So normally we use y, right? Because function value is y. Suppose I'm asking you if the answer is y, what does mean by that? That means question is like this. Hey, if you put y, what value for the angle, you will get negative 2 over 2. You understand the question?
Yeah.
Yeah. So basically, you are finding an angle whose sine value is negative 2 over 2, right? But remember, your y, your y is should be between negative pi over 2 to pi over 2 because we restrict our range. You see now
Yeah.
for the sine. So whenever you are asked to find the inverse function value, that is nothing but the function value. That function value is range, so it should be negative pi over 2 to pi over 2. Okay. Now use the unit circle technique and tell me for your y should be negative pi over 2 to pi over 2. Where is that? That should be either first or fourth quadrant. Am I right?
Yeah. I would say quadrant 4.
Yeah. Why it is quadrant 4?
Well, it's sine is negative.
Exactly. Sine is getting negative answer, so your answer is supposed to be here. First quadrant always positive. Okay, sine of which angle should be negative 2 over root 2?
7 power 4, or let's say 8, 7 power 4.
You are very close, but 7 pi over 4, even though this is giving sine negative, but this is not correct because your answer is supposed to be in this range. 7 pi over 4 will be somewhere here. Am I right?
Oh, yeah, yeah.
So always look your answer within this range. Understand? Even though your answer is correct, you could write, I know, sine of 45 degrees 2 over root 2. Am I right?
Yeah.
But now you are looking for the negative, therefore your answer is simply negative pi over 4. Now look at sine of negative 2 root 2 over negative 2 over root 2. Do you see that?
Yeah.
Your answer is correct, but this is not in our range. Our range is here, pi over 2 to negative pi over 2. So look for the answer within this range. But this value is not in this range. Do you understand?
Oh, yeah.
Because this,
Yeah.
if you figure out this is not in this range. This is out of this range.
Okay.
Yeah, that's what we restrict our range because to avoid these kind of things. Always you will find only one answer whose sign value is negative 2 over root 2, which is negative pi over 4. Okay.
Yeah. Yeah.
Now go to the second one. What is arc cosine 0? We don't know answer. Say y. The question is now finding cosine y should be 0. But remember again, your y should be O. Now look at the cosine function. For the cosine function, what was your range now?
0 to pi.
0 to pi. So you have to always look for the range. So you have to tell me the answer. Cosine of which angle will give you 0? That angle is supposed to be between 0 to pi. Cosine of what is 0? It is pi over
Pi over
2.
2.
Cosine
Right.
pi over 2 is 0. We are now good because this answer in this range, 0 to pi, right?
Yeah.
You see now, like that, you have to find out, the possible range for the inverse function. Let me go through these two very quickly. Okay. Now again, we don't know answer. Say why. The question is tangent of which angle should give you one. Okay. Now tell me the range of the tangent graph. Where is that? This is tangent graph. What was the range of tangent? Like sine, right? But only
Yeah.
difference is in sine we include the endpoints, but for the tangent we have just an open interval. We cannot include these two because remember, tangent function is undefined at these two. So you will not find any good number. So your answer y is supposed to be open interval, negative pi over 2 to pi over 2. Now tell me, tangent of which angle will give you 1 in this range?
Pi over
Pi over
4.
4. Very good. You are good now. You are understanding now, right? Getting better and better. Okay. The last problem. Oh, this is now not a good number, so you have to use the calculator, okay? Cosine of y should be 0.3. Okay, now ask yourself, what is the corresponding y value? Remember, your y should be, now problem is cosine, so 0 to pi. Am I right? Remember, your y is in radian, 0 to pi. Pi is 180 degree.
Right.
Do you see that, William? Okay, now tell me, this is approximately how many degrees? 1.26 radian. How do you change radian to degrees?
Mode.
Simply multiply the radian answer by 180 over pi. Okay, so I'm using the calculator now. 1.26 multiplying by 180 divided by pi. Where's pi? Do you see pi here?
Yeah, right there. Right
Yeah.
there.
How many
Yeah.
degrees? 72 degrees.
72.54.
Yeah, 72.2 degrees. So if you find the cosine of 72.2 degree, it will give you 0.3 answer. Makes sense, right?
Yeah.
Okay, so now this is the way to find the angles. Okay, so these are some properties you could read. Okay, our key point is now finding the derivatives of, inverse function. So you have to memorize these formulas, okay? Suppose u is a function of x, okay? So the formula says that the derivative of arcsine u is simply what? 1 over square root 1 minus u squared times u prime. The cosine is the same thing, but you will have the negative sign. Arctan derivative is u prime over 1 plus u squared. Okay. Arc cotangent u is again negative of tangent. Secant is u prime over absolute u times u squared minus 1. Okay. This all, if u is a function of x, right? If you replace u by x, you could rewrite all the formulas in terms of only x. If u is x, then what is u prime? U prime is simply 1. So if you're plugging
One.
these two values into this all formula, you will get what? The derivative of sine x, sine inverse x. Simply 1 over square root 1 minus x squared. This is the basic formula I'm writing here. The derivative of cosine inverse x is same thing but negative. The derivative of tangent inverse x, 1 over 1 plus x squared. Okay. So then derivative of dx of cotangent x, cotangent inverse x, same thing for the tangent but negative sign. You see that? Then derivative of secant x inverse, secant inverse x, it says that 1 over, you have absolute u there, right? So you will get x squared minus 1. And you see here,
Yep.
okay? So basically you could, memorize this all. Okay. Suppose in the problem, if you see here other than x, then use those function as u. Then use the formula here. This formula here, given formulas are set of common formula, right? You could be any function of x, but here I have written special functions all in x. Do you see that?
Yeah.
Okay. Now look at this problem. For example, the first one, you are asked to find the derivative of arc sine 2x, right? So
Yes.
inside the arc function, now you have other than x, keep this as u. So now use the first formula. If this is u, then what is u prime? U is 2x.
Two.
What is U prime? Simply 2, right?
Two.
Then
Yeah.
use this formula. Replace U by 2x. So you will get U prime, which is 2, over 1 minus U squared. Your U was 2x, so 2x squared. Do you see that? So then after that, simply use some algebra to simplify the problem. You understand? So basically we use here chain rule, right? Okay, that is there.